Okay, so from where we left off last time, we were trying to put all of these equations together. Remember I said that equations 1 through 3 for right now were the more important equations, and this would sort of be a useful tool later on when trying to solve the model. It provides an extra identity that makes some solution methods a little bit easier, and we'll see why later. But the idea was to take equations 1 through 3 and try to combine all of them into just one equation rather than having 3. Because personally, if I had a system of equations, I would rather find a way to reduce them down to 1 than solve all 3 simultaneously. It's just me. So what we did was we were going to use equation 1 kind of as like the baseline equation, the equation that is going to have everything shoved into it. So we started with equation 2, and here I've actually got everything color-coded because finally I found all of my markers that I had with different colors rather than just having one black marker. So the pink yt here, well, this is the same yt, so if y is equal to this, but y is also equal to this, then this is equal to this. So I just took the right-hand side of equation 2 and plugged into the left-hand side of equation 1. Booyah, right here. But then I still had this it, and it'd be better if I could get a way to substitute out the y or the it and have it in terms of something else that maybe this is in terms of. Well, we've got capital. So I took the right-hand side of equation 3 and plugged it into the right-hand side of equation 1 for it, giving me this right here. So I have at times kt to the alpha times lt to the 1 minus alpha equals ct plus investment, which is kt plus 1 minus 1 minus delta times kt. So this is what we have so far, which is good. We're making progress. We're getting somewhere with this model. But there's one more thing that we need to do. Now that we have everything kind of put into one equation, well, we can put this sucker in terms of per capita or per effective labor units. Why are we doing this? Well, right now this is aggregate. This is looking at everybody in the economy aggregated up, but what would be better is to think about this in terms of the individual. Because remember, the growth and development stuff we're talking about and what this model is attempting to address isn't looking at aggregate incomes. It's trying to look at per capita incomes. So we want this guy to be per capita. So what we do is we find a way to express this constraint in per capita terms. All right, so like I said, this guy's aggregate. We don't want this to be aggregate. We want it to be per capita. So if we want something to be per capita, how do we do it? Well, if we have aggregate incomes and we want per capita income, well, let's think about this. Okay, so aggregate income per capita. Well, per capita means per head, per person. So I have aggregate incomes. As long as I know the number of people in the economy, I can figure out what per capita income is going to be. Well, I do have an idea for the number of people in the economy. It's just LT. Right? So why is LT going to be, let me get this bracelet thing situated. There we go. So why is this LT going to help us find per capita income? Well, the answer is we assume everyone in the economy works. All right, so what's known as a simplifying assumption in this particular model is that pretty much once you're put into existence, once you're born, you are just assumed to automatically be ready and able to work, so you immediately get put to work. So there's no rearing time for children in this particular model. Why? Well, technically, if you want to think about it, children don't exist. You're just sort of born as an adult, and you immediately go to work. This is what's known as a simplifying assumption, in the sense that it simplifies a real-world component that would normally need to be considered into something that isn't super. It's something that needs to be considered, yes, but this model isn't addressing that question. So if it's not going to address that question, why are we going to want to be concerned with it? We can also think of it in terms of, this is everyone in the adult population. So if it's everyone in the adult population who is working, there's no unemployment, which there wouldn't be unemployment anyways, because we have perfectly efficient and competitive equilibria in all of the factor markets. So all the labor markets, all the capital markets, output markets, everything is good, everybody's working, there's no unemployment here. So if everybody in the economy works, and LT is the population. So if we divide everything by LT, then by construction we divide everything by the population. So we take this equation here, I hope you don't mind, I'm just going to write it all in black. So we just divide everything out by LT. So what happens here? Well, what happens is, let's start with the left-hand side to see what happens. We start with the left-hand side and write it like this. Oops. So you can think of it like this. So we're dividing these endogenous variables by LT. We're going to have CT over LT. Have this. So if you think about it this way, LT over LT is just 1. Well, I'll just write all this stuff out too. Like this. Now I'm just going to simplify some more stuff out. Now this is all per capita. So what we do when we convert to per capita we're going to just write all capitalized variables as lowercase. So this is going to give me Now my K's kind of look like capital or lowercase whenever I write them. And this is what we get. So the L is still in here, right? Implicitly speaking, it is still here. Because everything here, technically speaking, has an L under it. Let me show you what I mean by that. I'll write it for one of the variables so you can see what I am talking about. We'll do it for KT. KT, lowercase kt, per capita capital, try saying that one 3 times fast, is equal to aggregate capital divided by the population. So this is the amount of capital used by each individual worker. All right, let's look at consumption. Rewrite that just a little bit. Lowercase c equals capital C over capital L. Well, this lowercase c is capital C over capital L. It's the amount of consumption that each worker engages in. So all of these guys being lowercase means it's per capita. Now, because it's just sort of a nice little convention here, I don't see myself giving you an aggregate constraint. Maybe I will. No, actually, I probably won't. No, I'm not going to do that. What I'll do is I'll give you everything for all these equations that are already per capita. So you won't have to make anything per capita. You won't get anything at the aggregate. You will, however, get stuff per capita, and then you'll have to combine the equations. So, this is expressing everything in per capita terms. So now that we have that, let's go ahead and get to talking about some other stuff. And I know I say let's go ahead and do this a lot. I don't really know why I say it. I love how it sort of removes any actual responsibility of me doing anything, because it's not I am going to do this, it's I'm going to go ahead and do this. Kind of like that guy in Office Space, like, hey Peter, if you could just go ahead and try to finish those TPS reports on time, that'd be great. Instead of just finish the effing TPS reports on time. It's interesting. It's an interesting world we live in. But enough deep thoughts with Jeremy. So we're going to talk about what's known as the planner's problem. What's the planner's problem? Well, what we have here is a consumption savings decision problem. And what's the definition of a planning problem, though? Definitions might help. Okay, got done writing all that crap. So, in a planning problem, there is no market where an individual may earn any interest income from savings, but rather savings yields production following this transformation rule f of kt. This is the production function, f of kt. There's a benevolent central or social planner who allocates resources in the economy in a Pareto efficient way. So is this a realistic assumption? Probably not. Is this a nice simplifying assumption to allow us to solve the model to try to get some sort of baseline understanding of the dynamics that are driving economic growth and development? Absolutely. Now, this isn't saying that the government is solving everything out, that the government knows what the optimal allocation of resources is. Why is it not saying that? There's no government component in the GDP equation or the expenditure side of the national income accounting equation. There's no GT term in there, so there's no government, so the government's not planning this. Who's planning this? We are. Right? We are totally, we're basically God. It's like allowing a God or some deity to solve out how the society is going to work. So do not confuse that because we are solving this, we are technically the government for this economy that we're looking at. We're not. We don't want to conflate those two. So let's talk about the welfare theorems of economics. All right, so there are two welfare theorems of economics. When these two welfare theorems are satisfied, we have Pareto efficiency and we have competitive equilibrium in markets. So what's a competitive equilibrium? And then we'll talk about Pareto efficiency. in a competitive equilibrium, but you didn't think you'd be writing this many words after the lecture that you just saw. But a competitive equilibrium is an equilibrium condition where the interaction of profit maximizing producers and utility maximizing consumers will guarantee all factors of production, capital and labor, are paid their marginal products. And the price of output is equal to the marginal cost of production. Let's talk about Pareto efficiency. Pareto efficient equilibrium. And we'll say there is no alternative allocation whereby redistribution of resources will make anyone better off without making someone else worse off. So Pareto efficiency would therefore imply that, because really any kind of redistribution, if I take something from you and give it to somebody else, so if I take it from student A and then give it to student B, well, student A, no matter what I take, no matter when I take it, is going to be a little pissed off. They're going to be made a little bit worse off. Get out of the way so you can continue to write this down if you would like. You cannot be made any, student A will be made worse off to some extent, but the amount that student B benefits from taking something from student A is what's going to be of concern here. Because if I make student A worse off by 10 units of utility, but I make student B better off by 12 units of utility, right, that wouldn't imply that we were in a Pareto efficient allocation before I took anything from student A. But if I take something from student A and I make them worse off by 10 units of utility, but student B is made better off by 8 units of utility. Chances are we're in a Pareto efficient equilibrium. There's a Pareto efficient allocation of resources that currently exists. Now, in the Solow model, we are assuming that when we solve everything out, there is going to be a competitive equilibrium. We are also assuming that there is a Pareto efficient allocation of resources. So in a competitive equilibrium, right, there is no economic profit to be extracted from any particular markets. Everything is paid its marginal product. Price is equal to marginal cost. So if you remember from principles of micro, right, the marginal product of capital is equal to the rental rate of capital. The marginal product of labor is equal to the wage rate. So factors of production are paid their marginal products. The rental rate on capital is earned for capital. The marginal product of labor, the wage rate, is earned for labor. We are also in a Pareto efficient equilibrium, or a Pareto efficient allocation of resources. Right? If we have a competitive equilibrium and there's a Pareto efficient allocation, I'll underline Pareto efficiency, you know exactly what I'm defining here. If we have a competitive equilibrium and a Pareto efficient allocation, well, we actually get something kind of neat, where we have these two welfare theorems of economics being satisfied. So now that I've defined what a competitive equilibrium and what a Pareto efficient allocation of resources is, we can talk about the welfare theorems of economics. So what are the welfare theorems of economics? Or definition time with Jeremy. We will define the first welfare theorem of economics. Now, I write THM for theorem. So anytime you see the letters THM, that's theorem. Under the first welfare theorem of economics, a competitive equilibrium will yield a Pareto efficient allocation. So what this says is, if we achieve a competitive equilibrium, if we achieve an equilibrium where all factors of production are paid their marginal products, price of output's equal to marginal cost, we get Pareto efficiency. So if the competitive equilibrium is achieved, it will guarantee the existence of a Pareto efficient allocation of resources. So we'll call CE a competitive equilibrium. And we'll call PE a Pareto efficient allocation. What this says is that a competitive equilibrium, if we can achieve a competitive equilibrium, that will imply the existence of a Pareto efficient allocation of resources. So this basically says if we allow the market to work, if the market works to achieve a competitive equilibrium, we will get a Pareto efficient allocation. Now, a nice way to sort of think about this is if the market is operating, if we let the market work, then we will achieve Pareto efficiency, right? Everyone won't be equal. That is not what this says. What this says is that I can't redistribute resources in any way, shape, or form that will make one party better off without making another party worse off. Right? So this isn't going, everybody gets free access to health care, or it's not going, oh, well, you know, the rich just get richer and the poor just get poorer, or the rich get to prosper because that's what we need. We need the rich fueling the economy. There's no political argument to be made here. All right? There is no politicized economic argument to be made. What this is saying is there will still probably be some kind of disparities in incomes across individuals within the country. This does say, however, let's say I want to take $10,000 from super rich person and provide $10,000 of health care to a super poor person. Well, if that poor person is made much better off than that rich person is made worse off, well, that could guarantee a Pareto efficient allocation. By that same argument, if there were a set of circumstances leading up to this decision to redistribute were changed just a little bit, these parameters were changed just a hair, and I took that $10,000 from the rich person and gave it to the poor person and gave them $10,000 of health care, if they're not made much better off, that rich person's probably going to be made worse off than they're going to be made better off. So we can see this is not an argument for egalitarianism. This is an argument for how one party would benefit should we redistribute resources, take resources from another party and give it to them, and how they would benefit relative to how the other one is hurt. So anytime, of course, as soon as I'm done saying this is not a politicized economic argument, I'm about to make a politicized economic argument through example, of anytime you hear more right-wing or market-oriented policies, that we should allow the market to work. We should allow the market to ration everything via the price mechanism, and that doing so will allow the economy to prosper, allow everyone in the economy to prosper. They're making an argument that appeals to the first welfare theorem of economics. Let's talk about the second welfare theorem of economics. And the second welfare theorem under the second welfare theorem of economics, a Pareto efficient allocation yields a competitive equilibrium. So in this case, Pareto efficiency implies competitive equilibrium. So if I were to take resources and redistribute them in a way where I can't make anyone better off and anyone worse off, and then allow the market to work, allow production to exist, allow people to go to market and buy output that has been produced, then as long as we begin with a Pareto efficient allocation, we will achieve a competitive equilibrium. So here, what I'm doing is I'm going, if we have a structure in place that allows the market to operate in an efficient way, price equal to marginal cost, marginal product of capital equals the rental rate, marginal product of labor equals the wage rate, we will achieve Pareto efficiency. Here, this says if we achieve Pareto efficiency prior to production occurring, but we have a Pareto efficient allocation at the beginning, we will achieve a competitive equilibrium. Now, you can see these two theorems imply one another. They're the converse of each other, right? So here, competitive equilibrium implies Pareto efficiency. Pareto efficiency implies competitive equilibrium, which implies Pareto efficiency, which implies competitive equilibrium, so on and so forth. So these two welfare theorems of economics are satisfied under the assumptions of the Solow Growth Model. Let's talk about another thing here. erase all of these. They can all go. Define something else. A general equilibrium, you have to salute a general equilibrium, is an equilibrium where all markets clear, meaning there's no excess supply or demand. So in microeconomics, you dealt mostly with partial equilibrium. You would look at the markets for guns and butter, right? But you were not assuming markets for all other goods. So let's say if we're looking at the market for guns. Well, if there's a shock to the market for guns, that's going to have spillover effects in other markets that aren't markets for guns. Now they could be substitute markets, they could be markets, my brain just completely died out, I don't understand why. I got plenty of sleep last night. So gun markets, there could be substitutes, there could be complements, right? And there could be goods that just aren't related. Those markets will all be affected if we're looking at a general equilibrium, there's a shock to the gun markets, all other markets are going to have some kind of an effect. There's going to be some kind of a response. Now, under a general equilibrium, if all markets are in equilibrium, all markets are clearing, there's no excess supply or demand in any individual market. So these markets are all interrelated in some way, shape, or form. Changing one market is going to change the other market. Leads us to another definition. Of Walras law. This is a long one. So, Walras' law. It's a principle in general equilibrium theory that asserts the budget constraints imply the value of excess demand or supply must sum to zero. Every market has to clear. All variables follow an optimal decision path. Thus, if we had n markets and the first n minus 1 market, so if we've got 10 markets and 9 markets clear, the nth market, or the 10th market, would also have to clear. If I have 20 markets and 19 markets are in equilibrium, the 20th market is also in equilibrium. So if we can solve, let's say we have 2 markets. If we can solve for one of those 2 markets and force that into equilibrium, then the second market also has to be in equilibrium. If we've got 3 markets, we can solve for equilibrium in 2 of the 3. The third one is implied to be in equilibrium. And that will terminate this particular video because we will get to the slope of the production function. Actually, technically, we've already covered that. We will get to the solutions of the Solow model and the steady states of the Solow model in the next video. So, till next time, peace.